So more fun from stuff coming out of storage. My wife and I are going through our final boxes since we moved that we had in storage. And this one box that I started going through, I found a bunch of stuff that I thought that I had gotten rid of. Either donated, I thought it was a donate, I guess it was a box that I thought I put things in and then my wife had donated because I just wanted them out. Well, of the things that were in there were two of these RAVPower 67 watt hour lithium ion battery packs, and I bumped this thing. They've not been powered on. Well, one I powered on and it should be fully charged. Nope, that's not it. This one's 100% charged. So this one is the one that I have it's like the light comes on, but it's not doing anything. None of the outputs come on, and then you press the little flashlight button, it goes off right away. So it's like very much dead. And so I thought, well, this is really cool. I wonder if these things even work. So I plugged in this one to start charging it, and it started getting really warm. Well, in a certain area, it started getting really warm. So I unplugged it really quickly, and I was like, screw it. I don't really care about this thing. So I just destructively tore it apart to see what was inside of it, and to see if I needed to, go run and throw it into the explosion containment tube, whatever I called it, so that I don't conflict with Big Clive's trademark on the pie dish. Anyways, so I tore this thing open, and there was really nothing wrong at all. It was just kind of more of a moment of like, oh my gosh, this thing hasn't been charged up in 2 years. It probably had been pressed on while it was in storage, and the thing just, it not only self-discharged, but was also pushed into discharge, probably because it was turned on and off a whole bunch of times. So I thought, well, I ripped it open. Why not do a video on one of these RAVPower battery packs to see, how well one of these things were made. I had thought that these were actually bag cells, pouch cells. And I was pleasantly surprised when I tore it open and I actually cracked the plastic on this. So I might see if I can 3D print something to re-enclose all of this. But for right now, whatever. But when I opened it up, I was pleasantly surprised to see that it actually is 18650 cells. And yeah, I destroyed this thing. But it still works. And there are a few things that I was pleasantly surprised with regards to the construction, because this unit was quite cheap. These were less expensive than the Anchor units for the comparable capacity. The enclosures on the Anchor products are generally a little bit nicer. Now granted, this is a 3-year-old power pack, so RAVPower has probably moved on and they don't even make these things anymore, but it gives an idea of the general construction of a pack like this. But what's really interesting is that this is all operating on a boost topology. It is not bucking at all. So you have 7 cells. All of the cells are in parallel with one another. So you can see there's one massive link here for the positive terminal. And if I pick this thing up, there is, I gotta be careful because it looks like that's loose. I don't know if you can see it on the camera, but like when I move it, it looks like, oh God, it's loose. But it's actually mounted to a tab on the battery, so it's just a tab moving on the battery. But if I move it enough times, I'm sure I'll break it. But on the back, you'll see there's the negative terminal, and you can see there's a wire that runs back and forth from the top to the bottom to bridge the two negatives to get together. So basically you just have positive to positive, boom, 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 going like that. And then this strip at the bottom bonds all of them together, and then one negative comes back all the way across to here. So as far as the batteries themselves, I'll put a shot up here for the batteries. They appear to be, based on the part number, which is this LS LR18655K, which is just the 18655. I think maybe it's a little bit longer than an 18650 cell. I don't know my nomenclature of lithium-ion cells well enough, but I think this might be I'm sorry, it is an 18650 cell, LR1865SK. When I was searching for it, I kept doing the 55, and that's why I wasn't coming up with anything. And then this other number, DU0988, which turns out that it's this manufacturer that it appears that these cells are actually protected cells. So maybe at the time, maybe RAVPower still does this. It appears, and I haven't really had the desire to take one of these apart. Maybe if I find a dead cell, I'll open it up. But like, I think what they've done is they actually have protection PCBs on each one of these cells, which is why you couldn't put them in series. They have to be in parallel with one another. Otherwise, there's no common reference. And these protection circuitry cells require a common reference, at least the last time I checked, to be able to determine like what is the voltage on the cell. So if you put them in series, the cell that is, let's say you have a 2 series configuration, the cell on the bottom here knows common 0 volts to whatever voltage is here, 4.2 or whatever it's charged to. But then the next one, this negative wouldn't know. It would be referenced at 4.2 volts. It would be referenced at 0. So anyways, likely the reason why they put these all into parallel, plus it's also way easier to charge it. There's no balancing required, nothing. You just put a positive terminal here, a negative terminal on the back, charge up to 4.2 volts about, terminate, and you're good to go. One curious thing is that they did also include the ubiquitous, I'll use a little pen pointing device here, but they did use the DW01 and the dual MOSFET package. It's sitting right here under some silicon, I think it's just like a silicon epoxy. That leads me to my next point, which is they actually put silicon epoxy on all the batteries so that when you put this thing in here, the batteries aren't just sitting right on the case. Nice touch. You have some fish paper, insulative paper, that is pulled back over the bent back tab, so it's not sitting right on the plastic of the lithium battery. Nice. And then all the batteries actually have fish paper over the bus bars and the terminals. So this has fish paper. There's fish paper here. Not exactly sure. Yeah. So it's fish paper this way, and then they must have run a tab around. I'm not sure how they're getting I'm not sure how they did that, but anyways, there's fish paper here, and then on the bottom, of course, they also, on the bottom they did not, but on the bottom it's like a dual layer of plastic on the bottom of this thing. There's a false bottom that goes all the way through that this thing is sitting on. It looks like it just like as a channel for it to sit. It's not. It actually goes all the way down through this. So there's this, and then there's some support, and then there's the bottom. So that's fine. They also put a tiny little piece of polyethylene film tape over the positive terminal so that it's not just exposed. So you're technically double insulated between the outside world, the plastic, and the positive terminal. The negative terminal, they didn't put anything on it, I don't believe. So no, negative terminals are just exposed, but they are tabbed on the opposite side. So it's pretty difficult for this to go all the way up here, go around, and then touch and and short out. And so, let's not break that. Okay. And then the terminations, they actually put silicon epoxy over that, which I've seen a lot of cheap battery packs where they just solder that down and leave it. And these terminals, if they were to touch each other, like, it's a unlikely situation to happen, but it's a good practice to have a second level of securement to the printed circuit board. And so usually that might be like a through-hole connection that's soldered, so you're through the hole and then you solder it down, or you use something to adhere it to the board. So yeah, So the heat that I was feeling, the warmth that I was feeling around, actually, if I put this one in its place, it was, oh, this is upside down. That's right. So if I flip this around, the heat was coming from over here. So if you flip it back around the other way and open it up, you can see that it's not where a battery is at. And it's from the charging port coming in. You can see where there's actually exposed aluminum. There's some heat spreading, and then they also do, you can see there's some stitching through the board. These little holes that are all over the place. The stitching helps. You're electrically bonding probably the top and bottom layer so that you get more square area that's passing the current to be able to get, this is coming in at 2.4 amps perhaps, so 2.4 amps. It's quite a bit of current going into this cell. And then going back out, this is why this wire is so beefy. Going out, this thing is rated at 5 amps max. Now that's 5 amps max at 5 volts. So this could be as low as 3.2 volts. So that's about a 20%. I'm not going to do the math, but I'll just guess on it and figure it out later. It's about 20% or more. And so that could be up to 6 or 7 amps coming across this wire. I'll correct myself in post, but 6 to 7 amps coming across this wire. So that's why it's so beefy, because everything is in parallel. There's no build up of voltage to a higher voltage to reduce the amount of current and thereby the I squared R heating. So the amount of current squared times the resistance in this wire. So you need a pretty big chunky wire and a lot of fat traces to keep this thing cool. It was cool for a while because it was going through a pretty cool mode that I think Big Clive and others have discussed on their channels, but I'm also going to show because it's pretty cool, which is this mode where the charge protection circuitry is kind of like checking the lithium batteries, nudging them up a little bit to see if the voltages start to climb. And if the voltages don't climb, or they climb too quickly, it just goes nope and stops. So it did that for a while, and I was kind of watching it going, what is it doing? And then I remembered watching those videos, and I was like, that's pretty cool. And so I wanted to hopefully capture it on this one. It may not happen because this one seemed like it was more dead than this one. This one, the backlight wouldn't even come on. But this one, the display won't come on. It won't even say what percentage it is, and usually it'll show like 0%. So let's see what's going on with this. So I'm going to flip this one back over again, and you can see when it's functioning, it shows 100% out and all that good stuff. So we're going to jump start this one with this other one. So I'm going to grab this is one of these packs that has the high output current ports and then the lower output current. So I'm going to go with the high output ones. And that's this one. I'm going to flip this around and turn it this way. These packs, annoyingly, it's one of the reasons why I didn't keep using them and didn't like them as much, is that they had this feature where they would turn themselves off if the quiescent draw was not high enough. If it was less than 100 milliamps, I think it was actually quite high. It was like 100 milliamps, it would just turn itself off. So yeah, you can see already that the meter, it won't even keep the meter powered. So anyways, meter comes on. Let's see what happens. Go. All right, so I'll turn this on. Find the power button. Wait for the display to come on, and then I will plug it in and we'll see what we get. Anything exciting? Oh, unfortunately, no. It went right up to its maximum current. So, nothing exciting there. Oh well, it still makes for a good video to show the teardown. But you can see what is its input? Its input actually it's interesting. It's rated 5 volts at 1.8 amps, but it's pulling 1.92 amps. No wonder the thing gets so hot. It's pulling way higher than what it's rated by about 10%. So finding it kind of interesting. But anyways, the other one, the behavior on this display was that it it was like at about 0.4, 0.3, so 200 to 300 milliamp. And you can imagine, like, spread across 7 cells, it's like 60 to 70 milliamps per cell. So it's not pushing a lot of current in to each individual cell. It seems like a lot, but they're all in parallel, so there's not a lot of current going in. So, well, sorry we weren't able to capture it. It does appear, interestingly enough, that it is backing off pretty rapidly here. So it started off really high, and now it is backing off to around 1.6. So I don't know what's going on there. That's an interesting phenomenon that I hadn't noticed before. But then again, I don't charge these packs. Well, I haven't charged these packs in over 2 years. I didn't, again, like I said in the beginning of the video, I didn't even know they existed. But the interesting thing is that it's really backing off. That's really interesting. I don't know why it's backing off so much. 5 volts, 1.8. It should be 9 watts is about where it should stabilize. So I don't know if this one's got I don't know. To keep an eye on it. So anyways, I don't often charge things with the analyzer on it. So yeah, I wouldn't really know how this thing is supposed to be behaving. But it is, I do find it interesting that it is sitting here well below 1.8 amps. And this is plugged into a 2.4 amp port. So I'm not sure why it's backing off so much. Maybe this thing goes through some sort of charge conditioning for the cells. I'm kind of curious now to see what's going on. Anyways, that's the teardown of the RAVPower RP-PB26, which is a 18,200 milliamp hour at 3.7 volts or 67.3 watt hour battery pack. And the construction actually is surprisingly good, and my concerns about it being super hot were unfounded. And I can tell right now this area is getting warm. Just to show, let's see if I can show it with the infrared camera or the infrared thermometer. I don't know if this is going to show up on the. Yeah. Let me put the backlight on. So it is. So there's the cells. Cells are all around here, and they're 71 degrees. It is 68.6 in here right now, 69.6. So yeah, a little bit warmth around the cell areas. That cell seems to be a little bit warm. They're all in parallel, so it really shouldn't matter. One cell gets unhappy, then it'll just shut everything down. But you can see, you can see right there. Look at that. I don't know why why is this in Fahrenheit? I must have bumped this. Sorry about that, everyone. Oh, and the backlight turns off. So there we go. Oh, and my spot turns off. And the backlight turned off again. There we go. So yeah, getting way up to 40 degrees, 42. I mean, that's fine. 50? 50. Wow. Yeah. I don't know if a 50 is right. That might be a slight reflection off this somewhat shiny enclosure. But yeah, everything else is really cool. Anyways, that was a quick look at the RAVPower power pack that I discovered that I didn't even know I had still. And so I guess I'll let this thing charge up. I'm going to plug it into the wall instead of it just, wasting energy between the two packs. But we'll see what happens when it's fully charged again and see how it does. I am planning on doing a discharge test on these packs just to see what their capacity is. I don't know. The only problem is they won't stay on, so they shut off. And so I'm trying to do a test, and I need to get a load that's like a I like to make use of the power that I've stored in these cells, but it seems like it's going to be one of those things where I need to plug in a bunch of LED little lamps or something to like get a consistent draw so I can actually get a reading off this thing from start to finish. Yeah, they were used heavily for solar and a bunch of other things, so I am expecting that they're probably not going to have much of their original capacity. But if there's anything else of interest that comes out of this, well, I will make a follow-up video of this wonderful 3 to 4 year old RAVPower Battery Pack. I actually do not know when I bought these. Maybe I will go dig through my Amazon history and find when I bought these things. It may have been as far back as 2014. They may be actually 5 years old. Wow, that's crazy. I did see on the circuit board that they were marked 2014, but that's when they were manufactured. They could have sat for who knows how long. So yeah, I guess I'll look and put on there. I think it might be 2014, 2015 timeline. So it could be these are 4 or 5 years old. Interesting. Well, yeah, I guess I will see what capacity one of them has, and if it makes it into the timeline, I will throw it into at the end of this video or do a quick follow-up to show what the capacity is. Anyways, thanks for watching, and if you like what you saw, give a thumbs up, like, subscribe, comment, do all that stuff, and I will see you in the next one.